Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Stanley number CB179 4.5 4.5 NRP 26D. And this video will serve as visual evidence of the item, dimensional evidence of the item as well. I will say up front, I'm a unapologetic fan of Stanley. I love their fit and finish. I love the quality of their hinge. This is the first time in the recent past I'm looking at a CB179 ultra smooth movement. Ultra smooth movement on this. Okay. The reason I like the fit and finish is the manufacturing of hinges is not an easy endeavor. These are hard to make. I've seen how they're made. These are difficult to manufacture. And when I see a manufacturer who consistently puts out very good quality fit and finish, it tells me that they really have their act together. One thing that here are the things that I look for. And maybe not so much with a 652 hinge or a 26D, which means made of steel with a satin chrome plating on it. What I'm looking for is the finish on the inside of the crotch of the hinge. Here, here, and here, here, and here. And it's good. And a hallmark of good manufacturers is when you're dealing with a oil rub bronze or a brass plating or a finish that is a bit quite disparate than what the natural color of the base material is. To me, that's a hallmark. I'm also looking for what the leaf looks like in this sort of orientation. Okay, and it's nice and consistent. I'm looking to see how well the leaf just swings naturally. This is incredibly smooth, and that tells me that you're going to really get very good efficiency out of the door, meaning the door is going to open nice, but your closer is not going to have to grind that hinge down every time it opens and closes because it's already operating very smoothly. You know, you need a reduced opening force to be handicap compliant. You need a reduced closing force, and a hinge that swings freely is going to permit the door closer to do its job efficiently without it having to fight or for the door closer to overcome, hardware problems, hinges that aren't super smooth, latches that don't latch, and frames that aren't true plumb level and square, etc. So it's a good looking hinge. So what I like to do with hinges is begin with a dissection of the part number. This is a CB, and that stands for concealed bearing. This is, and I don't know the statistics, but you could get an FBB170 or an FB179, just a typical ball bearing hinge on this 5-knuckle hinge, non-concealed. But the concealed bearings, because of the material science involved, are able to handle a greater, they're about 20%, and about a 20% lower coefficient of friction. So they do operate smoother right out of the box. And plus they're better looking hinges as well. You don't have those giant bearing packets that you see. What would be here and here on a standard weight hinge. So let's move this to the screen view where we can dissect that part number and better understand this hinge. Okay, so this is the item that we're looking at here. Here's our part number, CB179. It's a 4.5 4.5 satin chrome hinge. This happens to be the non-removable pin version that we're going to go over here. Medium weight doors of average frequency, that is true. That's based on not only the thickness of the leaf, which is 134 thousandths, which is what we call standard weight, but it's also the height of the hinge. 4.5 would be considered medium average frequency doors. If we kick that up to 5-inch, now we're dealing with a door that might be a little wider, a door that might be a little heavier. Standard weight versus residential weight versus heavy weight. Standard weight means 0.134 inch thick. That's the leaf thickness. This hinge is made of steel, and that's inferred with this number right there. Okay, that's 7. Well, that's 7.9 actually. tell us that it is a standard, that it is a steel-based hinge. This is their lifespan. I think it's lifespan bearing. I don't know that it's lifespan. I thought it was lifespan. Concealed bearing, so you don't see those bearing packets. This is a reversible hinge should you need to turn it around for some reason, which I'm not sure why you would, because it can be left hand or right hand. You can drive that pin out should you want to with a hole in the bottom pin tip for easy removal. We have some documents that are here: template, hinge installation, and hinge size chart. Yeah, I don't want to get to any of these just yet. Let's look at the link to the manufacturer's page here. And then we're going to go to the architectural hardware catalog. The 2010 version is the one that I like because it gives me the information I need on a product that hasn't likely changed in decades, like the CB179. So and as we get through our introductory portion of the catalog, we do, yeah, it's lifespan, not stan, lifespan. And we'll get to that page where we can see the cut sheet. And here it is. Okay. CB179, lifespan. This is actually not the correct CB179 because that's a slip-in hinge. Let's continue on looking for our hinge. Here it is. Okay, here's our hinge. CB179 means, 179's mean, or the 79 means steel. You can do a 191, which would mean a non-ferrous base material such as brass or bronze. You can do that in a stainless with a polished finish, or a stainless base material in a satin finish. For medium weight doors of average frequency, we're going to look at the weight chart in a moment. And I do see where that typo comes in. It comes in right there. It's lifespan, S-P-A-N. Maintenance free and attractive. So there is your material science is inside of these knuckles that make this greater than a traditional ball bearing hinge. Okay. Options that you can do on these hinges are listed here, such as raised barrel, electric through wire, hospital tips, decorative tips like ball, urn, steeple tips, ball, urn, steeple, and acorn. There are others. Other manufacturers have those. I don't know that Stanley has all of those. With a non-removable pin, we're going to go over that in a moment. These are all the sizes that this hinge is available in. They'll do it in a 3.5 by 3 all the way up to a 6 by 6. Okay. Now, what needs to be also looked at is they can do this in a CB199, which is the same hinge, except that now it's a heavyweight hinge, which would be, depending on the height of the hinge, it's going to be 180 thousandths, maybe 190 thousandths. And here we are with a CB199. Here we are. So it's same hinge. The range of size is now different because this hinge is 180 thousandths thick, which ought to be here. Yeah, right here. So 4.5 is 180 thousandths. So it's, you know, almost 50% thicker, and you can get that up to an 8 by 8 hinge, and that gets really thick there. So if you have an application that is a heavier door or higher frequency use, I said CB199. What I meant to say was 168 because that's the steel version. The 179 is the standard weight steel. The 168 is the heavyweight steel. The 199 is the heavyweight non-ferrous version of the 191. So forgive me for that misspeaking in that way. So it is a 5-knuckle hinge. Let's get to the weight chart that they have here. Stanley does an exceptional job with giving you an idea of what hinge that you should use based on the weight of the door and its frequency of use. You know, a CB179, you've got a, let's say, 150-pound door, 4.5, 4.5. That's going to be pretty much, in my opinion, the cutoff for a standard weight door in that size. You need to go a little bit heavier, use the same CB179, but you're going to go from 4.5 tall to 5 tall. That gives you about a 20% increase in efficiency. And right at about 225 pounds is when you're not going to see a standard weight hinge anymore. And you're going to go heavier than that, then you're going to go to the heavyweight version. And then larger heights. Just larger heights. So you'll need to calculate what your weight is. You know, you can just come up with a square foot weight rating for your door and then multiply that by the size of your door and come up with a good hinge. I like the Stanley catalog because I'm familiar with it and I know where they put this information. And the first several pages of the Stanley catalog is an encyclopedia when it comes to understanding hinges, what they are, the different types. We've talked about their hinge guide in terms of the weight and size of the door or the frequency of use. This is how you calculate a wide throw hinge, by the formula that's here. You should always be looking at this formula, in fact, to determine if on our 4.5 by 4.5, is that the right width of hinge? It might be too large. You might be better served by a 4-inch wide hinge, or you might need a 5-inch wide hinge, a wide throw. Okay. Speaking of door weights, they've provided that for you. Here's a table for your use. Different types of fasteners. Different types of hinges are also going to be, these are finish charts that are here, by the way. Then different types of hinges. Full mortise, this happens to be a 3-knuckle version. Half mortise, half surface, full surface. Swing clear, this would be a half mortise swing clear. This is a half surface swing clear, full surface swing clear. Anchor hinges is what these are called in the industry. They call them pivot reinforced full mortise. This type of hinge is not very often used, but there are architects who specify it, and it will keep your door and frame working very healthily because of how that hinge is. You know, then you can continue on. Now, here's where we get to non-removable pin, and this is what we're going to talk about. The non-removable pin is a set screw in the barrel that intercepts the groove in the pin itself. Here's your pin. That pin has a groove cut in it, and when you tighten that set screw, that set screw is going to bury itself into the groove cut in the pin. That renders it all but impossible to remove. I've tried. Not without destroying. I've tried to do it without having the proper tools. I found it not possible. So you would always use non-removable pins. You would always use a security feature when you have an exterior outswinging door or an interior door that swings out and you want to render the removing of the pins to get the door off the frame is something that will be substantially less convenient. If you have a higher value area, you might want to consider the security stud. As you see here, that when that door is closed, that stud's going to go right inside of that hole. So even if you were to drive the pin out, that's fine. You're still not going to separate the leaves very easily because of this condition. And then, of course, you can take those posts and put them back behind the into the frame prep itself. And you'll see that in applications where you really can't have anything projecting. This hinge has a hospital tip on it, and then there would be no exposed studs there. That pin wouldn't come out, and even if you were to do so, the door still should not separate because you have those projecting posts into the hinge plate on the door and frame. Okay. Raised barrel is another type of hinge, and you can look at that here. This is not a raised barrel hinge, but if you have questions on that, feel free. Wide throw hinges. You use that clearance formula I mentioned earlier, and it's again here. And then how we define hinges in terms of them being full mortise or full surface. Okay, a full mortise hinge is going to have both leaves swagged like this, whereas it will look like this when you lay it flat on the table. Well, if you, and you would not therefore surface mount this, but with a full surface hinge, you would not have any swag on the hinge leaf. You could then surface mount that. Okay, one leaf swagged, you know, would be an application where you have, it does kind of look like a raised barrel hinge, even though a raised barrel hinge has a special preparation done to the leaves. But you could do an application where you were swagging only one leaf, maybe because of a special condition that you had. Nothing comes to mind immediately why you use a one leaf swagged hinge is what I'm driving at. Okay, so let's switch back to the camera view and take a closer look at the hinge and then wrap up this video. Now this is the set screw that we're talking about. Slotted set screw. If you pull that out, you'll be able to then drive that pin out. When you're done, seat the pin and retighten the set screw. Okay. Now what's nice about this design is from the outside you don't see the set screw. From the one side you can see the set screw. From the other side you obviously can't. But when you if you were to try to get your tool inside of there, you know, when you're standing on the pull side of the door, I can't get the tool there because the head is mostly concealed. You can prep your own non-removable pin. I've done it myself. I've drilled and tapped holes into barrels. The pins will generally already be grooved. It's like that's the only way they make the pins, certain manufacturers, so you want to measure off where that is. The important thing is that you get that set screw drilled very close to the surface of this leaf so that you can't get access to it from the outside. If you were to put it over here, that would be an easy bypass. So be mindful of that. That's the swag on this full mortise hinge we were talking about just earlier, right there and right there. That's what makes this full surface, because when the leaves are brought together parallel, they're meant to be mortised flush to the edge of the door and frame. I got to tell you, I'm really impressed. Stanley just really impresses me with their hinge. Their hinges are going to include screws, naturally. These hinges include all wood screws and all machine screws. Do not anticipate that that's how they're always going to come, because they don't. Absolutely, best practice would be is that you specify at the time of order in the comment field what you want in terms of screws. This could very likely come with half wood screws and all machine screws. And you might call on a Saturday and you're standing there and you have no access to 12 by 24 threaded to the head, you know, machine screws, or I should say sheet metal screws that match the finish. So specify that. It's technically not proper to not specify it, because again, you may not get the screw count that you want. Stanley hinges are nice because they include shims as well, and those shims are just cardboard shims. Now they sell these in a box of 100 or 500, whatever it is, I forget. That you can break those off. They're perforated, and use that to tip or cant your door in the direction that you need. Move it out, move it in. Be mindful you would not use cardboard shims on a fire-rated door ever at all. And as the old joke goes, if you do, be sure to use your competitor's business card. That would be a violation of, under scrutiny of a fire door inspection. Anything cardboard shimming a door, or anything non-steel shimming a door, would be a violation of the fire rating of that door. So don't use those at all. We can sell you steel shims. Back to the extended description, just to make sure we've covered all the bases, which we haven't yet. The pattern of the holes are template pattern. The size of the hinge is 4.5 by 4.5. The height is always the first dimension on hinges like this. Always. It's not the way that doors are sized. The width of the door is the first dimension. I like to, you know, no one's ever explained to me why that's the case, but I believe it to be because the first dimension is probably the one dimension of the two that is a little more important, a little more defining of the opening. And indeed it is for doors. I don't care that it's 7 foot or 6'8", but I do need to know the width. How wide of a door are we talking about? 3 foot? Okay, great. Now what's the height? With a hinge, the first dimension is more important because it's directly related to, as we talked about earlier, the weight and frequency of use. If you need to kick up your capacity on a hinge, you don't go to a wider hinge. That would in fact work against you. You go to a taller hinge. That makes it, I think, more important of a dimension. Now the second dimension, the width, is very important when you're calculating clearance. What you want is that vertical axis of pivoting as close to the center of the door as possible. A 4.5, 4.5 may not be the best way to use this style, may not be the best hinge for your application, and in many instances it's not. And you know, people who manufacture hinges tell me that they make 4.5, 4.5. It's not the right hinge in most applications, but it's because what distributors want. And here's a little conversation of why you might want to scrutinize that a little bit further. Now we're going to refer to our formula to determine the width, but before we do that, let's take a look at, let's illustrate the point. If we have a frame, a door and a frame, okay, we've got our hinge here. Where we place that vertical axis of pivoting is going to end up being really important. We do, again, want that as close to the center of the thickness of the door as possible, because it permits the hinge to be more efficient at carrying the load. Now, in an application like this, where we have our door, okay, what really determines the intelligence of the width of the hinge, the dimension from the center line to, let's just say, the face of the door or the face of the frame, is really dependent on what's happening in all of this space. Okay, if you have a stud, you know, a partition wall, okay, and let's say you want that door to go to 180 degrees, well, you know, do you really need a 4.5 inch hinge? You don't. A 4-inch wide hinge would be better, and while it's not substantial, it's only a 1/4 inch, it is considered best practice to do that. Now, what would cause you to really need to further think about what's happening is, what if you had, you know, 8-inch block, okay, and that frame is being put in with a T-anchor, okay, what's the degree of opening? You know, what is this dimension? Do you have to think about it? Is it important? Yes, it's always important. And let's look at that, because this is the way that we're going to go about determining it. So the formula is door thickness minus back set times 2 plus the clearance and adding any inset. So what that means is take your door thickness, let's say 1.75 inches, times 2 is 3.5. Pardon me. The formula is door thickness minus your back set. 1.75 inches minus a 1/4 inch is generally what it is. That's 1.5 inches times 2 is 3 inch. Then comes the clearance. What clearance do you need? If you need 0 clearance because of our first example of having nothing to get around, well, then it's 3 plus 0. And that inset is probably about 3/32 or less in a typical wood door steel frame, steel door steel frame, etc. So you then use the next largest size, and in our instance it would be a 4.5 by 4. But you can also see, if you had 8-inch block and you were centering that 5 3/4 frame in that opening, we're going to have, well, it's actually 7 5/8 minus 5 3/4 divided by 2. You know, you could easily have a 1-inch a 15/16 clearance requirement there. Okay, so back to our formula. If we had 1.75 minus the back set times 2 is 3 inch plus our clearance of 15/16 plus our inset of about 1/8 inch, yeah, you know, then use the next larger size. So 3 plus 3 and 15/16 plus another 1/8 inch or another 1/8 inch, you're going to be at 4 and, you know, almost 4 1/8. Best practice there would be to use a 4.5 inch wide hinge. Well, by extension, you know, what if you had a clearance requirement of 1.5 inches? The point of the matter is we need to be thinking about what is the best width of the hinge. The height is super important, but we can be more intelligent by thinking through how wide of a hinge that we want to use. Now back to our hinge, let's click on template. The location of the holes for the screws is what's called a template pattern. Might be easier to look at it, you know, like this. That's a template pattern. I don't know the year or the decade that this was considered standard, but it was very likely at some point mid-century or maybe the 1960s that the template pattern came into play. The reason that that's important is because, you know, in the 19th century, a particular manufacturer sold you everything. You know, it sold you the locks and the hinges, and all of that you could get in the same finish. Well, what if you wanted to use Stanley hinges, but you wanted to use Corbin locks? Their finishes would not have matched. When you standardize on the pattern of the hinge for the holes based on the height, you can then use everyone's hinge on everyone else's door and frame. So if you have something prepped for a template pattern, it will always match these locations that you see drawn here. Okay, so that's what that template pattern is. This hinge will apply to many different part numbers, and it's all on one template. There's also the hinge installation document, which you know, is an important document. If you are certainly new to the world of hinges, I would read this. Stanley, I believe, owns National. And what's really most important to take away from this document is the equal portion. Obviously, no manufacturer is really going to observe 6-inch and 10-inch, but many of them, well, in fact, all of them will be basically equal in this sort of regard. The formula that's creating this is for doors up to 60-inch, up to and including 60-inch. You're going to have 2 hinges. You get past that, for every 30-inch, you're going to add an additional hinge. I was saying earlier about National. I believe Stanley owns National. National is a company that has been in business since, I think, the very late 19th century. A lot of steel goods, strap hinges, track and trolleys for barn doors, things of that nature. Okay. Document that shows how a door swings here. This is showing you the what would be the egress side of the door, the interior of the opening. That's a right hand, but it could also be a left hand reverse if this became the exterior. Right now it's drawn as the interior side. Not much else there that I think we need to cover. Why don't you do that if you like. Hinge size chart. This is not appropriate because it's a national document. So we'll have that pulled out of here by the time you're seeing it. Okay. Finishes. It's made of steel, which means that they can do your brass, your bronze, your chrome, your nickel, satin, polished, oil rubbed. But it will always be a steel-based product. So polished brass, you know, obviously they can do black, they can do prime coat as well. But you get into your chrome, your nickel, your bronze, there is no substitute to have those finishes done on a non-ferrous base material. They will look wholly different. To the trained eye, they will at least. But this is a steel-based hinge that would be appropriate for interior use. Let's finish up this video on camera. So we've got a really high-quality hinge here from Stanley. There's a link below this video back to the manufacturer's page where you can pull up not only all of the Stanley products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog that we had been to. The name Stanley is synonymous with many other product lines, however. Stanley is now, it'll probably change by the time you're seeing it. These mergers and whatnot always seem to evolve, but they're tied in with Kaba, Precision, Best, obviously Stanley, who knows who else, obviously National's underneath there somewhere. A large conglomerate of companies, or, you know, that, I believe it might be called Dormakaba is the actual conglomerate name. they're attempting to field complete solutions. You know, hinges, locks, closers, exit devices, the whole 9 yards. I find Dorma, Kaba, Best, Precision, Stanley less so. No, that's not true. All of them, when I contact their technical support, I get an exceptionally responsive, prompt, I should say, expert, professional, complete, and thorough answer to the question. I don't need help on a hinge per se, but if I need to know something more esoteric, something not published, they're responsive all the time. And questions that are quite obvious to them. What is this piece used for from a Best lock? You know, if you don't have any experience in it, you need to rely on expert technical support, and they've got that. And thankfully, the industry that we work in, that's pretty much become the norm to have exceptional technical support, and Stanley definitely carries their weight in that department. I'm an unabashed fan of Stanley. I would suggest that you review their product line before making a final decision. Any questions on the Stanley? This is their concealed bearing, their CB179 4.5, 4.5, and a 26D NRP version, or any other Stanley product. Please feel free to reach out to us. And thank you.